we're very fortunate to have Luis here. You know, I was doing a little calculation because I know Farming Smart is going to do a trip to Brazil. So I think I'm going to have to put that into my budget. I haven't been in Brazil. I saw it across the river from Argentina, and so I need to step into Brazil. I've been asked to talk about advanced nitrogen fertilizer management. You know, and at first I thought, oh, this is an easy subject. Well, it's not really an easy subject, and I'll mention just a little bit about politics because, you know, the problem with environmental programs is they really do. Yes, somebody yesterday talked about one size fits all, and you know, nitrogen management in Ontario is completely different than nitrogen management in our drier prairie climate. And for example, those of you that put your hands up, those that soil test the farms, okay. And you do the majority of your soil testing in the fall. Okay, all the hands up. If we were in Ontario, they don't soil test in the fall because of their mild winters, their rainfall during the winter, the leaching, the denitrification. What they would measure in October near Guelph, Ontario, and what they would measure in April can be completely different. And so they do most of their soil testing for nitrogen in the spring because that's more relevant to their crop. So, you know, some of these programs, like, you know, when we first, with climate change, we've all heard reduce nitrogen by how much? How much is it, pardon? Yeah, 30%. And then there were some confused things because people were sort of pushing back and saying, well, what do you mean 30? Like, they said, oh, well, no, we meant reduce the emissions by 30%. Well, okay. So, for example, if you put nitrogen on in a more humid climate, and I'm picking on Ontario, the problem with Ontario agriculture is it's all being turned into cities. You know, we had some very productive farmland that doesn't exist anymore. And so they're left with us out here in the dry area to grow the food. But normally under their conditions, if they put nitrogen fertilizer on, at least 5% of it will go off as nitrous oxide into the air. Under our conditions, most of our nitrogen, maybe a little more under irrigated, but not a lot, 0.5 to 1% goes off as nitrous oxide. And so one size does not fit all. So when they brought up this program and said, if we reduce our nitrogen rates by 30%, we can really reduce the nitrous oxide emissions. But you know, out here we don't emit we have a lot of farmland, so when you add up that 0.5 to 1%, yeah, our agriculture contributes to nitrous oxide emission to the atmosphere, but you got to realize we're doing a lot of things. Our climate limits what kind of losses we can get there. So I'll just jump ahead. Now, plants only use nitrate or ammonium. And nitrogen as nitrate will move in the soil with the soil water. And so it's quite mobile. Ammonium is very less mobile. It acts like a cation, so it's acting like calcium and magnesium, and it sticks to the edges of the clay particles, moves very slowly in the soil. The reality is, if we could place all our nitrogen fertilizer where the roots are going to go, and we'd keep it absolutely as ammonium, we could increase our efficiencies. The plants actually expend energy. They absorb nitrate through their roots, and then they expand energy to change it back to ammonium before they start making proteins. And so it's been proven in hydroponic systems that if we just feed ammonium to the wheat plants, we can actually get a higher yield. But in reality, in our climate, ammonium doesn't stick around too long. There's some bacteria in the soil that make their living changing ammonium to nitrate and then to nitrate. And then it moves in the soil. And it's good that it moves because otherwise where we're placing it, it wouldn't get to the roots. So just realize that's happening in the soil. Nitrogen is very essential to plants, especially protein. And the protein's important to us and the animals and so forth. We don't see a lot of nitrogen deficiencies in fields because we're so well trained to put on nitrogen, supplemental nitrogen. But if we do get it, we get spindly plants, yellowing of the older leaves, and so we do see patches in fields. But generally we don't see like large nitrogen deficiencies because our farming system is very efficient at putting nitrogen on. Now, it's good for us to look at a simplified nitrogen cycle. And I'll show you what the terms are that are coming. So the majority of nitrogen is in the atmosphere. We're breathing it right now. It's 78% dinitrogen gas, rather inert. We breathe it in and out all the time. We can't absorb any of that nitrogen and convert it into proteins in our bodies. But the plants, once the dinitrogen gas is converted over to ammonium or nitrate, then the plants can change it over to protein. And that's important. Now, we call that the process of moving it from the atmosphere to ammonium and nitrate fixation. And that happens ways then that mineral nitrogen, ammonium or nitrate can move back and forth to organic matter in the soil. When it goes into when the microbes immobilize it into organic matter, we call that immobilization. When the organic matter decomposes and there's a release, we call that mineralization. We can have losses on leaching. We'd like to have more leaching out here. It would, we lose very little nitrogen due to leaching because we just don't get enough rainfall. But in some parts of the world, leaching is very significant. And then, of course, what we want to maximize, I don't know if I can only show it on one screen, is we want to maximize uptake into the plants. I can show both sides, yeah. So that's what we want to maximize. And the natural ecosystems cannot supply nitrogen fast enough to grow the high-yielding grain crops, forage crops that we need. Does anybody know what if we, I have some environmental divisions of my extended family, and I remember the first time I met my niece's new husband, and so my niece comes up, "Hi, Uncle Tom, this is my new husband." Well, the first words out of this fellow's mouth was, "Oh, you're the uncle that works for the fertilizer companies that's poisoning the world." And I go, "Okay." I said, "We need to talk." And but we do have to supplement. But does anybody know how much less food if we went like my niece and her husband? They got an organic farm in Oregon, farmed it for about 6 years and couldn't make any money and had to go get a real job after. But what percentage, how much less food would we produce worldwide if we quit using? 80%. Yeah, I've heard 60%. But so if all of a sudden we had 60% less food available everywhere then we'd have to decide who gets the food and who doesn't, okay? And that would politically, that would be big problems. Now, the fixation part is important. Under natural ecosystems, there are bacteria in the soil that are capable of doing that. And, but we make a lot of nitrogen fertilizer. And we get quite a bit of nitrogen coming out of the organic matter. It's part of the cycle. But there are ways that we can lose nitrogen. So we burn all this natural gas to make nitrogen fertilizer. We produce it, we sell it to farms, it goes out to farms, and then we can lose it once it's applied. Denitrification is when we get wet conditions, the microbes run out of oxygen, they can't get enough oxygen, they take the oxygen off the nitrite or the nitrate, and then it goes back into the air as mostly as dinitrogen gas, but then that 5% under wet conditions, 1% under our conditions goes off as nitrous oxide. So yeah, I always hear this, they put nitrogen fertilizer on and it goes off as nitrous oxide. Well, no, even the loss part, it's 95% goes back as nitrogen gas. But it's a big waste of money and energy. We spend all this money to make nitrogen fertilizer, and then when we have it's too wet and we get losses, it's back into the atmosphere. We do have volatilization losses. So this is when you put a urea form on the surface and you get a little bit of ammonia going into the air. Now, it doesn't go way up in the atmosphere. It floats around. It's heavier than air. It'll come back down, but not always where you want it on the land. And then we can have leaching. And like I said, we'd like to have more years of possible leaching in our climate, but we don't. We're in a semi-arid climate. Now, how are we doing? So this is the big one that environmentally we try to avoid, denitrification. And so what happens is when the nitrate, this is when the microbes run out of oxygen, there's not enough air in the soil, they have to keep functioning. And so not much oxygen. So first they go for the oxygen that's either on nitrite or nitrate. And it can be considerable. Under the wrong conditions, you've put on nitrogen, you've had really good conditions, it's all been changed over mostly to nitrate, and we get really wet conditions for a week and a half, 2 weeks. Then you can lose up to 50% of the fertilizer you put on. It will be denitrified back into the atmosphere. And so it can happen. Usually we try and do things to avoid that, and I'll talk a little bit about that. I talked about volatilization and leaching, so I'll save some time. But I want you to realize how nitrogen fertilizer is produced. And part of my talk, I think there's a huge research program out of the University of Toronto, and they're looking at the natural way, low energy ways that nature accomplishes a lot of industrial processes. And so on those of you that grow alfalfa, lentils, peas, the bacteria in those nodules, they convert dinitrogen gas over to ammonium. And they do it biochemically using enzymes that they have built into their biochemical systems. And it takes energy to do that. They get the energy, it comes from sunlight, the plants do photosynthesis, the plants share sugars with those bacteria. They convert dinitrogen gas over to ammonium. And so that's part of their deal with the plants, and the plants give them sugars so they can live and so they can do that. Now at a fertilizer plant, we actually, like in the plants here in Alberta, we take natural gas, we put it in a sealed vessel with a catalyst, and then we heat that vessel burning natural gas. So natural gas is both the feedstock and the energy source to make the nitrogen fertilizer. We break the bonds between the methane, the CH4, and the hydrogen, the carbon and the hydrogen, they save the hydrogen. And does anybody know where they get the nitrogen from? Yeah, all they do is react the hydrogen with the air. Well, again, in a sealed vessel, and they add some heat and have catalysts to do it. So they just get the nitrogen from the air, but they need that hydrogen first for it to react with. And then they make ammonium. And then once you have ammonium, you react it with other acids mostly. You react it with nitric acid, you can make ammonium nitrate. If you react it with carbon dioxide, you can make urea. If you react it with sulfuric acid, you can make ammonium sulfate. If you react it with phosphoric acid, you make ammonium phosphate fertilizer. But without that first step of getting the dinitrogen gas over to ammonium, we don't make the rest of the fertilizers very well. Well, there's some we could, but so back to the nitrogen cycle. What we want to do, we want to maximize crop uptake. We want to minimize losses. And, we used to, initially, we only broadcast fertilizer. Then here in Western Canada, we did a lot of work especially under our no-till systems of band placing the nitrogen. It was a big, huge step forward. This is, if you look at this, I showed the amount of loss. The least lost is the top bar. Now I've made two of them red, so you can see the one on the far right is no-till planting, banding the nitrogen at the time of planting. And I know this data because I did this research. This was my master's research. And we were able to get the loss down to less than 4%. So we were actually getting 95%, about half of it was going into the crop, half was being stored in the soil. And then, 45 into the plant. But we had less than 4% nitrogen loss. Rather quite efficient. Now, if you go back to the far, let's go to the middle one, which is under a tilled system, broadcasting it, then cultivating, planting the crop. Without banding, our losses were basically doubled. We were up about 11% losses, which isn't terrible, but by placing the fertilizer, we were able to increase that. So there's a lot of things we do in our cropping systems that are actually quite efficient with nitrogen use already. We band place most of our nitrogen, especially in the dry land areas. And, but on some of the large farms, logistically, it takes a lot of labor and it costs more to band all the nitrogen at planting. So on some of the large acres, it's a lot easier to broadcast the urea and then just plant. You could save a lot of time. You could get planting done on, let's say on a 40,000 acre farm, you could probably get planting done 2 weeks earlier by broadcasting and not banding all the nitrogen at planting. But you got to realize you're going to have a little bit higher losses. So what do? You put on extra nitrogen to cover those losses. Agronomically, you can grow equivalent crops. Now, environmentally, is that good? Well, that's not, if we have higher losses, that's probably not what we want. But, so, I was involved in a study. We compared spring banding to broadcast in the fall, broadcast in the spring. And depending on the year, sometimes the broadcasting worked fine. So you got to realize nitrogen is very reactive in the environment, and we can do everything wrong, but if we get the right conditions, it can work out fine. And then sometimes we can do everything to minimize losses, and if we get the wrong weather patterns, we're still going to have losses. It's just the way nitrogen is. So how am I doing? I'm going to stay within my time. So, there are things we can do to prevent some of these losses. If a farm could come to me and say, this is how much we have in our soil, this is the crop we want to grow, we're going to actually get rain this year and be able to grow our target crop, or as much rain as we want, I should say, or need. And this is when we're going to get the rainfall. We could look at that year and we could design a nitrogen application system that would be extremely efficient, because we know when the rain's going to come, and are we going to have potential losses, then we could add inhibitors to decrease those losses. But the problem is we don't know exactly when the rains are going to come. And like for us, the worst thing that can happen, we banned our nitrogen in the spring at planting. We have pretty good conditions. It all gets changed over to nitrate. And then we get 2 to 3 weeks of really wet conditions in early June. That's when we could lose up to 50% of our applied nitrogen. Now, normally we don't get that. And so it's usually not a problem. But, you know, maybe 1 out of 20 years, we're going to hit those conditions where no matter we've done everything what we think is the best, we're still going to have losses. Now, if you knew that was coming, we would put high rates of inhibitor that would keep the nitrogen as ammonium and prevent it getting changed to nitrite and nitrate. And then we really could reduce those losses significantly. And we'd economically, what we'd pay for that protection to prevent denitrification would pay off. But most of the time we don't need to do that much. So, you know, I wish I had news about how to really increase our nitrogen use. And the more I thought about it, I thought, you know, the reality is we actually use nitrogen fertilization methods in our cropping systems that are actually quite efficient already. There's not a lot we can do to make it more efficient. And, you know, there's new technologies coming. I guess the only thing I could think that they could develop would be something that you could attach the nitrogen to, that the only way it would be released is if your crop plant releases a chemical from its roots that releases that nitrogen, and then it's into the plant. But we're looking at the whole system of the soil and the plants, and it's very dynamic. And you know, I guess what I'm saying is there's not a lot we can do to make more efficient use of the nitrogen. And by decreasing our rates by 30%, all we're going to do is lower our crop yields. And so I hope this 30% reduction thing will sort of blow away in the west wind, and maybe it'll stay down east where it's supposed to. But with that, I wish I could say more. You know, there's this new technology you can use that we're going to increase nitrogen efficiency into our crop from 50%, you know, to 90% into the crop. But I'm not aware of, unless we do it in a lab, how we can do that in the field yet. And with that, thank you. I'll try and keep us on time here. So.
Appreciation. Oh. Is any questions for Tom? Because we do have a bit of time, and you know what? Coffee's not that important anyway. You can always do coffee afterwards. Because I have a question for you. Do you have any comment on some of these new and up-and-coming nitrogen sources, like some of the biological stuff and stuff like that, or is that outside your purview of knowledge?
Well, you know, some of the new biological sources, the reality is if we can mimic what some of these microbes can do, but under the natural ecosystems, they have very low outputs of nitrogen. Like in a forest system, natural forest, the microbes probably fix about 20 pounds per acre, 25 kilograms per hectare of nitrogen a year naturally in the system. And for those natural systems, that works good. That little bit of nitrogen input is stable. But all of a sudden, when we want to grow, 140 bushel barley, we need a lot more nitrogen than that. Does that make sense? So there's some promising technologies, but it's we haven't had any really home runs yet on the nitrogen side. Yeah. There's a question over here.
Just two quick things. The first thing, why do you think like half the nitrogen was just staying in the soil? Was it just that the yield wasn't that good that it didn't need it? And then the other thing, like when they broadcast, well, fall or spring, do you think it just happened to get the right rain and snow? Because if I broadcast it and leave it, I mean, it's gone. It's just going to all get cooked, right? So.
You asked two questions. You get 2 for 1. That's pretty good. That's good strategy. But so say the first one again, so I can answer it right. Oh, you were asking about what's left in the soil. That we're not going to change that. It's the microbes. They can get the nitrogen. They're better at getting it out of than the plants are. And so when we put nitrogen fertilizer on, what ends up to our crop, like it looks bad at first. You say, well, even your best one, you got 45 or 50% into the crop. Well, yeah, but it's displacing nitrogen from the soil into the plant too. So the important thing is our losses aren't high. Does that help? Yeah, so we can rarely feed all our fertilizer right into the plant. It goes into the soil, then there's some that comes out of the soil to the plant from previous applications. Yeah. Okay, and then your second question was about the
broadcast, would you
yeah.
not
Well, I worked on this study for 4 years, and so we did fall broadcast, spring band. Of course, our hypothesis was that spring banding's always going to be the best. And it was never the worst. It always performed well. But we had years when fall broadcast and spring broadcast did just as well. We had enough rain to take that urea into the soil. We had very little losses. So that you need enough rain soon enough so you don't have those ammonia losses from the urea. If the worst thing you can do is spread urea on wet straw and soil, and then don't get any rain for about 2 weeks. You have nice breeze. That's when you get more losses. If it stays really dry, it'll just sit there too. But there's always a little bit of moisture. And so you need enough rain soon enough after broadcast, take it into the soil, then it's actually just as good as banding. I hope that helps. Yeah.
Yeah, I spoke to the government about out east, about the 30%. Originally, they wanted across the board 30% reduction.
Yeah.
Then, of course, with the public outcry and so on, they changed it to voluntary 30% reduction. How much reduction in yields would you get if they implement? Of course, down the road, they'll change their mind again and go back to the original idea of mandatory reduction. So how much less yield would you get?
Now, there's a lot of factors, but I would say if we could reduce our nitrogen, and I think we'd probably have 20% lower yields. Yeah, like it's not as bad a news. If they would have said 50% reduction, then I would have got worried. But like a lot of our farms do things a little more efficiently, use some of these inhibitors when we know losses might be possible. We could get by with lower rates a little bit, but not, I would say more realistically, if we could reduce our rates 10, 15% and still keep our yields up there quite well. Does that, I hope, now that's off the top of my head, but
Well, I thought it'd be more reduction.
no, it's not as, in some ways we could make them happy by just, okay, let's decrease by 30% and then we use a lot. The trouble is we'd still have lower yields, yeah. But if we'd get higher grain prices, that could balance out. See, but it's not as simple as what they say. The environmentalists say just reduce the rate, because what happens when you get up to the higher rates, the optimum rates, any little bit of extra, you get slightly higher emission losses. And that's why they really push for, well, let's reduce it 30%, and then we'll minimize losses. They're right, it would, but we'd also reduce our yields, yeah.
Can you speak at all to lobby efforts regarding trying to move the needle on that? I assume that like Fertilizer Canada is lobbying the government about that, but are you aware of any of that, and if the needle is being moved at all?
Well, you know, I think a lot of it is a bunch of bunk. And I say that because it's sort of like my colleague Luis said, you know, the big thing is the fossil fuel burning for transportation and industry. You know, we get pointed at in agriculture, and yeah, we need to do our part to try and reduce greenhouse gas emissions. But, you know, in my opinion, we're not the big elephant in the room. And, you know, we're producing food, and sometimes I think we get targeted. You know, like, I think it's even worse for the pork cattle industry. You know, they say that the cows fart out methane, which is wrong. Well, there might be a little bit, but it's mostly they're burping it up from their rumen. And, you know, my goodness, we used to have, what, I forget how many millions and millions of bison in North America. They were all burping methane. And so you can tell I'm a little biased. I think agriculture, we're being targeted a little too much. That doesn't mean we can't make improvements, but I sort of skirted around your question, didn't I? But yeah.
I got a follow-up, George, sorry. I kind of, I don't know if infiltrated is the right word, but I'm participating in a group that has had tremendous lobby efforts for sustainable ag. You know, and I think we like to get up and say that we need to do our part. I do 100% agree that we're being unfairly targeted, but there are ways to have a stronger voice in that message, and I think there are ways for us to have a positive impact and be part of that discussion. I was actually in the Prime Minister's office last week with this group discussing those issues. So it makes me uncomfortable, to say the least. They understand that the West has obviously pushed back against it, but when I see the amount of investment going towards this, and of course, environment and climate change, their job is now to find megatons to meet the climate exchange. So they're also looking to agriculture as part of the solution. So I guess my question then to you is, if we had to really put our thinking hats on for Western Canadians, what types of investments or practice changes could we do to at least come back with some positive change? And I'm always for investment in agronomy, which I see failing. I don't see any real connection to the farm. So what are your thoughts on that front?
You know, and I think where we could really make some is that put more money into that research at the University of Toronto, so we could technologically get away from burning natural gas to make nitrogen fertilizer, and do it copy nature's way of doing it with a lot less energy. And then I think, because the amount of energy burned to make the nitrogen fertilizer is the CO2 is far greater than that little bit of N2O that comes off. So I think that's where we could really make some progress. Anyways, my opinion.
There's any on-farm things we can do as well?
You know, we're using our nitrogen about as efficiently as we can. I get a little upset, again, with my environmental parts of my family where they're really critical. And I say, they get this idea that farmers just spread lots of fertilizer willy-nilly on the land. And I said, they don't, because they can't afford to. I said, it's too expensive. And I don't know if we can do a lot more to do a lot more efficient.
At least on the nitrogen.
Yeah, on a nitrogen basis, yeah.
Thanks, Tom.
Okay, thank you.